So Miss Ross is gone today again, so you get Schlegel back. You're welcome. And so as we get going, everyone, if you were gone yesterday, you missed a really great video on how to solve equations that have fractions in them. But the good news is you get to get a second dose of it today. So this is going to be super uber important as we go forward. And so I did want to make a video for you guys, even though Miss Ross is not here today, so that we can keep practicing on this sort of thing as we go forward. So with that, I'm going to get started with number one. I hope this is helpful. I'll probably be seeing you throughout the day, and I hope that today is an awesome day for you. It's going to be your Friday. So, duck lips. We got a new sheet for us here today. The one yesterday was kind of long and stuff, so I put something else together. And what we've got is we're going to be solving these equations. And I know, again, that we all just love fractions, right? For me, anyway, that answer is a big fat no. So we need to recognize and remember the idea when we see things like this that we can do anything that we want to an equation as long as we do it to both sides. And so sort of assuming that you heard the conversation yesterday, we can multiply both sides of this equation by anything we want. We could also subtract 73 from both sides if we wanted to. Subtracting 73 wouldn't help us do anything, but we could. We could add 350 to both sides if we really wanted to. Because that would make both sides of the equation stay equal. We're not going to do any of those things, though, because they are not going to help us solve this. But understanding that we can do anything that we want to both sides of this equation is going to help us along the way here. So the reason that it's going to help us is because we can find a common denominator of these fractions and multiply both sides by it. Now I know that 5, 2, and 10 all go into 10, but let's say I'm having a hard time seeing that. I could multiply 5, 2, and 10, which would make 100, and that would still work. Any number that 5, 2, and 10 all go into will make this work. And so you could choose to use 10. I'm going to choose to use 100 because I went ahead and multiplied all of my denominators to get a number that I know is going to work. So again, we're multiplying both sides of this thing by 100. And it's the distributive property, so there's 100 times that 1 and times that 1, and 100 times that 33. Now remember, these 100s are over 1, and when we multiply fractions, we multiply numerators and denominators. So it's really like we're just multiplying 100 by each of the numerators in these fractions. And so if I did that, I would get negative 100 over 5. My denominator stays the same. Plus 100 over 2x, my denominator stays the same, equals 3,300 over 10. And especially if you weren't here yesterday, you might be thinking to yourself, why in the world would you do that? Now we just have bigger fractions that are even worse to deal with. This sucks. You're wrong. So what we can see is that negative 100 divided by 5 is negative 20. 100 divided by 2 is 50. And 3,300 divided by 10 is 330. And look, the fractions are gone. The reason this works is because if I multiply both sides by a number that is divisible by all of those denominators, the denominators divide out evenly, leaving me with no fractions. And now this is a very simple problem to solve. We've done probably a couple hundred of them like this by now. What we would do is add 20 to both sides. To finish this thing off, we would have 50. X equals 350. I need my fancy line like Miss Ross does. And then lastly, we would have divide by 50. And we get X equals 70. So I'm going to leave this here and give the sub an opportunity to pause this and give you an opportunity to take notes if that's something that would be appropriate right now. Then I'm going to move on to number 2. So number 2 coming at us, we have denominator, we have fractions in this, and so since we have fractions, we have denominators. I know that 2 goes into 4, so I will go ahead and use 4. I could also multiply 2 times 4. I could multiply all of my denominators and get 8. I could use 8. I could also use 12 or 16 or 20 or 24 or 400. Any number that 2 and 4 both go into would work to be used as something I could multiply by to make the denominators in this fraction disappear, because they're going to divide out evenly. So distributive property, we're going to multiply a 4 by both of those things, and we get 8 times 4 is 32, equals 4 times 1 is 4, over 2. Denominator stays the same. 4 times 1 is 4. Denominator stays the same. We bring down our x. Now we've got an instance where, again, our fractions look a little bit meaner, but watch what's about to happen. 32 is going to stay the same. Need the fancy line Schlegel. 4 divided by 2 is 2. 4 divided by 4 is 1. We've got our variable there. Now this problem is super easy to solve because I have whole numbers. I'm going to subtract 2 from both sides. I get 30 equals 1x, which is the same thing as 30 equals x. As I did on number 1, I'm going to pause here and give people time to ask questions or take notes. And moving on to number 3. Number 3 looks extremely bad. Like, wow, bad. Think for a moment of a denominator that 5, 3, and 15 all go into. I know that 5, 3, and 15 all go into 15. I could also use 30. I could also use 45. I could use 60. I could use any number that these three denominators all go into. Most people are probably going to choose to use 15. Again, we're going to multiply both sides by 15. The goal being that these denominators divide out evenly at the end. So we're going to have 15 over 5x plus 15 times 5 is going to be 75. And 60 times 15, I think, is going to be 915. Just did that in my head. I'm going to check out the calculator in a second. Plus 30 over 3x. And let's see what the calculator says. 15 times 61. Let's see if I got it right. Yep. Not too bad for an old guy. Okay, and so now, everyone, we're going to have fractions that are going to divide out evenly. 15 divided by 5 is 3. 915 divided by 15 is 61. 30 divided by 3 is 10. And so now I basically have an equation we've done lots of times in the past, or that this type of equation anyway. I'm going to go ahead and choose to subtract 61 from both sides. You could choose to subtract 3x, or there's lots of correct things that you could do here. I'm just going to choose to do this one. This is one correct thing I could do. And this is what I get. So now I am going to choose to subtract 3x. And I get 14 equals 7x. So lastly, my final step is going to be divide by 7. And I get 2 equals x. So again, the only new learning between yesterday and today is that we can have equations that have fractions in them. And the way that we handle that is we multiply both sides by a common denominator, or by a multiple that all of the denominators go into evenly. In this case, we chose 15. Again, you could have chose 30 or any other number that all three of those numbers go into. For number 4, we've got, I should go back here, I'll say pause if you need to pause so you can take notes and such, and I'm moving on. For 4, we have a situation where we've got denominators of 6 and 3. Now, some of you may see that 3 goes into 6, and so we could just use 6. Again, I'm going to pretend that I don't see that. A way to get a number that does work is just to multiply all the denominators together. 18 would also work. So we've got 6 would work, 12 would also work, 18 will work, 24 would work. Any number that 3 and 6 both go into would work to make this happen. So again, we've got 18 over here and 18 over here. Do our distributive property. And we get 18 over 6x. Let's see if I can figure this one out in my head. 18 times 12 would be 24 less than 240. So that would be 216. Again, I'll check that with the calculator in just a second. And that's 180. So 12 times 18. And for those of you that are wondering how I figured that out, I did 12 times 20 is 240. I need 2 less 12s than that, so I subtract 24 and I get 216. And that was correct. I just checked it on the calculator. There you go. How about that? Okay, so next we are going to have a situation where our fractions are going to divide out evenly. 18 divided by 6 is 3x plus 216. 6x plus 180. And so last time I did normally I like to deal with the numbers first. This time I'll go ahead and deal with the variables first. I'll choose to subtract 3x because if I chose to subtract 6x, I would get negative numbers and I don't want that. So I will be left with 216 is equal to 3x plus 180. And then lastly, I'm still got one more step to go beyond this. I would subtract 180. And we would have 36 equals 3x. Last step now, we're going to divide by 3. And we get 12 equals x. So again, the only piece that is sort of new to us is the stuff above the yellow line. Because below the yellow line, this is exactly like the questions you were doing on a test a couple days ago. And so again, remembering that the trick is that we need to find a common multiple that all of the denominators divide into or multiply into evenly. Then we multiply both sides of the equation by that number, and boom, the fractions are gone because they divide out evenly. I'm going to pause, then I'm moving on to number 5. Trying to move on to number 5. And with number 5, we have denominators of 7, 4, and 28. Well, 7 times 4 is 28, so I know 7 and 4 both go into 28. So I'm just going to go ahead and use 28. Now, just being straight with you, if I couldn't find a denominator that I knew was a common multiple of those 3 numbers, I would multiply those 3 numbers together, and I would get 784. If I used 784, it would still work exactly like it would if I used 28. I would just have a little bit bigger numbers to begin with, but I would still end up with the exact same solution. And if you're a person that wants to test that, go ahead. So we've got 28 over 7x. I think I'll do that on the next one. I'll have some like ridiculous number gigantic number that I multiply by. 28 times 55, That's a little bit difficult for me to do in my head, so 28 times 55 is 1,540. And so 28 over 7 is going to be 4x plus, and I forgot to do the next one, didn't I? That should not be 1 over 4. That should be 28 over 4, which is going to be 7. And then 1540 divided by 28 is going to be 55. So now we have a very easy equation to solve. We're going to go ahead and subtract 7 from both sides. I get 4x equals 48. Divide 4. And x is equal to 12. So again, just understanding that if we have fractions in our equations, we can find a common multiple of the denominators, multiply both sides by that common multiple, and the fractions will divide out evenly. I'll pause, and then I'm on to number 6, my last one for today, and the rest is for you. So in number 6, we have denominators of 2, 3, and 6. And as I mentioned before, I noticed that 2 and 3 multiply together to make 6, and so I know 6 would work. Let's say I didn't notice that, though, and I did 2 times 3 times 6, I would get 54. No, not 54. I need to use my calculator, guys. Getting tired. I get 36. So I am going to go ahead and use 36 in this one, like I said I was going to. If you use 6, which you can, you will end up getting the exact same answer that I do. Again, it can be any number that the denominators all go into equally. So I'll ask that some of you go ahead and try this one with using the number 6 instead of 36 and see if you get the same thing that I do. And if you do it correctly, you will, even though you chose to use 6 and I chose to use 36. So I've got 36 times 1 is 36. 36 times 1 is 36. Denominator stays the same. 36 times 2 is 72. Denominator stays the same. And 36 times 5 is 180 over 6. Denominator stays the same. So we can see that as I do this, my denominators are going to cause this to turn into whole numbers because 36 divided by 2 is 18. 72 divided by 3 is 24. And I forgot my plus sign. There we go. Plus 180 divided by 180 divided by 6 is 30. So there's lots of correct things that I could do here. I'm just going to go ahead and choose to subtract 30 from both sides. I could subtract the 36, but then I end up with negative numbers, and I don't like that because I think negative numbers are more difficult. So I'm going to go with 18x equals 24x plus, what the heck is going on here? Okay, Schlegel's getting goofy and making mistakes. That should say 30. So I should have 36 minus 30 leaves 6. There we go. And 30 minus 30 leaves nothing. See, look, even Schlegel makes silly mistakes from time to time. Own them, recognize them, do something about them. Okay, so next I see that I want to subtract 18x from both sides. And I'm going to get 6 is equal to 6x. Final step, I divide by 6. And I get 1 equals x. So, pretty nasty problem, pretty easy solution once we get the fractions out of the way. So again, the only new thing is just, Schlegel needs a nap, just the stuff above the yellow line. That's the only thing that's new. Everything else is exactly the way that we've been doing it up until this point. Everyone, I hope this video was helpful. I hope you have an awesome day and a great long weekend. Schlegel out.